All right, so a truck rental company rents a moving truck one day, and what is it charging? $31 plus 7 cents per mile. It says write a linear equation that relates the cost, C in dollars, of renting the truck to the number of miles driven. So step one is, can you write an equation that describes this situation? So C represents the cost. So I'm going to do a cost function. And what is the cost for renting the truck? Is $31 plus 7 cents per mile. And the word per is a good word to understand, means multiplying. So 7 cents per mile. And in this sense, C represents the total cost and X is the number of miles. The second part is, what is the cost of renting the truck for 120 miles? So once we have an equation, what do I do with it? And then you have your answer. If I know what 7 times 12 is, I can figure this out. So what's 7 times 12? 84. And then think of the 0 and the decimal. If you put it all together, that's $8.40. So altogether that would be $39.40. So the cost of renting the truck for 120 miles is $39.40. All right, try number 3. In number 3 it says to convert temperature from Celsius to Fahrenheit. Do you know how many countries in the world don't use, how many countries in the world use Fahrenheit? Apparently, I think there's 2. The United States would be one of them. Every other country in the world uses Celsius. That's right. So, I know, we are, right? You multiply the temperature in degrees Celsius by 1.8, and then what do? Add 32. Some people say it really quickly that you double it and add 32. Have you ever heard that before? Double it and add 32 to change it? Maybe not. I'll tell you that right now. Do you want a quick way to do it? You double it and add 32. But more mathematically, it's not doubling, but 1.8. It says express f as a linear function, even though that didn't come out, a linear function of c. Oop, I did it the wrong way. So F is Fahrenheit. What would I do to the Celsius as I multiply it by 1.8, and then what do you add to it? So F is in Fahrenheit, C is in Celsius. Do you know another way to do temperature? You know another, other than Fahrenheit and Celsius, you know another unit of measurement that measures temperature? Kelvin, right? Yeah, you scientists out there. So, but you can think what's fun to get to 0 Kelvin, right? Is absolute 0, which is impossible, right? Like infinity, right? Idea? All right. Not a science class right now. So use the equation to convert 18 degrees Celsius. So if I wanted to convert 18 degrees Celsius to Fahrenheit, could you do it? So if you had to, you would, right? It's at 324. And move the decimal. Did anyone else get 324? 18 times 18? Move the decimal. Does that make sense? A guy grew up with Celsius, so I know that makes sense. That 18 degrees is about 65 degrees Fahrenheit. Anyone else grow up with Celsius? Or you have a sense that would make sense? Number 5. The cost associated with fixing a washing machine is computed as follows. There's a fixed charge of $20 for the repairman to come to the house, and then there's a charge of $28 per hour is added. Find an equation that can be used to determine the total cost, C of X, of a repair that takes X hours. So we have C at X being the cost, and we know the cost is $20 plus $28 per hour, where X represents the number of hours. If the bill to fix your washing machine comes out to $188, how many hours did it take the repairman to fix the washing machine? So in this situation, am I plugging in 188 for X? Because X represents the hour. That's what I'm looking for. So instead, I actually know what C is. So I'm going to make it equal to 188 and then solve it. And think, how many hours is that? So subtract 20. Does 28 go into 168 evenly? Maybe. Yep. So how many hours is that? So the question is, how many hours did it take to repair it, right? It took 6 hours to repair the washing machine. All right, turn the page when you're ready. So, I'm going to let you do 6 and 7. We're going to do number 8 together. So again, the ones that we don't do, you can practice, because right now I'm doing them for you and you're kind of listening, and then you'll have to do it independently. So, number 8. Northwest molded molds, plastic handles, which cost 30 cents per handle to mold. The fixed cost to run the molding machine is $1,516 per week. If the company sells the handles for $1.30 each, how many handles must be molded and sold each week to break even? So this is a great question. All of you are very good at math in here, which I love. There are times when I teach a class and you ask a student, like, what do they want to do? And they want to run a business, right? And then the next sentence is they're not good at math, but they want to have their own business one day and be their own boss, right? Can you see how that's not going to work? And that if you're going to be a business major, a finance major, all that, you're going to need Calculus Plus to be able to run a business, do the things you need to do. So, here we are. Do you know what the word break even means to do with a business? There are 2 parts to a business. Be real simple. One part of the business is your cost. That's everything. The cost of your building, your bills, your employees, right? Cost. The other part is how much money you take in. That's called your revenue, right? What were you going to say it's called? Profit is different. So profit is when you take revenue and subtract your costs, and what's left over is your profit. But when I want to break even, revenue is equal to your costs. And when your costs are more than your revenue, you are then going to go bankrupt the way Forever 21 went bankrupt yesterday. Right? Did you know that? Anyone shop there? They're closing their stores? No? Now you know. Forever 21 is done. That's why. Why are they closing their doors? Because their costs are bigger than their revenue. Huh? Toys R Us is gone, right? Sears is gone, right? All these stores, right? Sears went bankrupt, but then whoever bought them, like, I don't know what they're doing. Still kind of alive? It's there somewhere. All right. So, do you know what the word break even means? Break even is when revenue equals what? So, break even is when revenue equals costs. So, how much does it cost to run the machine? How much does it cost to run the machine? Okay? Now, cost is running the machine. Cost is also how much does it cost to make each handle? 30 cents, right? And X is going to represent the number of handles. So on one side you have cost. So how much does it cost you? So at that 1,516 and also 30 cents per handle. What's the other side? Revenue. What do we know about how much money you're taking in? $1.30 per handle. So we set up an equation to solve for X. So we know how many handles do we need to sell so we can break even. And then if you sell more than that, you are now making a profit because revenue is above costs. Yes. All right. So how would you solve this? You would combine like terms. What's $1.30 take away 30? $1. $1. So that's just one X. It's over. So how many handles do you need to sell to break even?
1,000.
So you need to sell 1,516 handles to break even. So, quick reminder again. What profit is? Revenue subtracting cost, right? Break even is when revenue and cost are the same. Did you make any money if you break even? Okay. Number 9. That's going to be yours to do. Turn the page. Let's look at number 10. We're going to do those of course were linear, right? Polynomials. These are going to be quadratic polynomials. Stories. You ready? The manufacturer of a CD player. Have any of you ever owned a CD player? Yes. That's awesome. So, hey, what is revenue? Is how much money you take in. When the unit price is $P, if the manufacturer sets the price P to maximize revenue, what is the maximum revenue to the nearest whole dollar? So, the first thing I want you to recognize, and I'll talk over you until you stop talking, is that we're given an equation. So, negative 5p squared plus 1,510p. R is the revenue, and P is the unit price. What does that mean? That's the price per CD player. And obviously, what you set the price for determines the revenue. Now, if you say, why don't I set the price for $1 million? Well, no one's going to buy it, so you'd have no revenue, right? Why don't I set it for 2 pennies? Won't I sell a lot? Yes, but then how many do you need to sell, right? At 2 pennies. Get the idea? There's a number, right? Somewhere that would do what? Maximize. Do you know what type of polynomial this is? This is a quadratic. And when I see the word maximum, the word on the quadratic I'm looking for is the vertex. And to find the vertex quickly, I use the formula negative b over 2a. That gives me the x-coordinate. Now in this case, the x-coordinate is p. So in this situation, b is 1,510, and a is negative 5. So I want you to notice a negative divided by a negative is positive, and we're dividing by 10, which makes the answer really simple. Now, if the question is, what should you sell each CD player for? The answer would be $151. But the question is, what is the maximum revenue. So then what do I do with that answer for the maximum revenue? Is I plug in 151. If I gave you this question, would allow you to use a calculator. So even though you don't have one there, I'm going to plug one in into my calculator. And so what is the maximum revenue in this case? $114,005. Can you see if you run a business, you have to be good at math, right? If you work in a hospital, you need to be good at math. There's probably something where you don't need to be good at math at. But like the big stuff in life, I think you need to be good at math. So number 11, I'm going to let you do. Number 12. You are getting a business math lesson today, aren't you? The price P and the quantity X sold of a certain product obey the demand equation. What's the word demand mean for a business? Do you know? Do you know what the other word that goes with the word demand? Supply. And what do they both mean? So if I say that the CD player is 2 pennies, then the demand will be high because everyone's going to want to buy a CD player for 2 pennies. Yes? So then the demand is high, but the supply is going to be low because you're selling so much of it. If I say each CD player is $1 million, the demand is going to be low, but you're going to have a lot of supply because no one wants them. Yes? Supply and demand. So demand is how much someone wants it, right? Well, the supply is how much you have of it. Shark Tank, right? We watch this stuff, don't we? Okay. So, if you set the price P and you sell that much, that's the demand equation. And it says what quantity X maximizes revenue. Now, if you take your price and you multiply it by how many you have of it, do you know what you get? Is the revenue. If you take the price and you multiply it times how much you have of each one, right? That gives you the revenue. So X is how many you sold. P is the price. If I multiply them together, I get the revenue. So if I want to know the revenue, what do I have to do to P? Is to multiply it times X. So the revenue is actually X times P. In that case, P is negative 1/4 X plus 140. If you distribute, do you see that there's a quadratic relationship there? So how do I find the revenue? Is I take the price times how many you sold. So there's the price. I take the price times X. I plug in, and I have my equation. What's the maximum revenue? What's another word for maximum on a quadratic? The vertex. What formula gives us the vertex? Negative b over 2a. In this situation, what is b? Negative 140. What is a? Negative 1/4. So I know a negative divided by a negative is positive. I know 2 times a quarter. If you have 2 quarters, it's now 50 cents. And when I divide by a fraction, it's really times the reciprocal. So what did I really find here? What is X again? X is how many you sold. So how much did you sell? 280. Is that what the question asks? So in part A, it says what quantity X maximizes revenue. So what would the answer be for the first part? 280. That's for the first part. How would I maximize, what is the maximum revenue? What would I do with that answer? Is I would plug that answer in to my revenue equation. And again, I'd let you use a calculator if I gave a question like this to you. So then I plug in 280, and I'm going to use my calculator to calculate the revenue. So the maximum revenue is $19,600. So if I want to find revenue, what do? I take the price per unit times how many I sold, and that gives me the revenue. Does that make sense? What the price is, how many did you sell, you multiply it, and it gives you the revenue. And if it's a quadratic, and you want to maximize revenue, you find the vertex. And to find the vertex, it's negative b over 2a. Turn the page. I want you to turn all the way to question number 18. In question number 18, you have 220 feet of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the area. So let's break this down. First of all, what shape is my region? Shape is a rectangle. My goal is to find the maximum area, so it would make sense to know the formula for area. An area of a rectangle is length times width. Now, what do we have is 220 feet of fencing. If I put fence around my rectangular region, is that area or perimeter? So perimeter of a rectangle is twice the length plus twice the width. And what we found out was we have 220 feet for our perimeter. Now, the challenge with this is I have too many unknowns. So what I'm going to do is I'm going to take one equation and I'm going to make a choice. I'm going to solve for either length or width, and I'm going to plug into the area. So I'm going to make a choice. I'm going to solve for the length. So if I want to solve for the length, step one is subtract 2w. So I want to get L by itself and then use it to plug into the first equation. So how do I get L by itself? Subtract 2w. And then what would you do is divide everything by 2. So half of 220 is 110. 2 divided by 2 is w. And do I now know what the length is? So when I come back here, I can now have an area function to do with width. Because where there's an L, what am I going to plug in? Is 110 subtract w. So I solve for the length. Where there's an L, what did I plug in? 110 subtract w. And now I'm going to distribute. And I have an equation to know what the area is. So if the width is 1, I could plug it in, or 2, or 3. But I want to know which w would give me the most area. So when you hear the word maximum, what word should come to mind? Vertex. How do I find the vertex? Is negative b over 2a. So for this quadratic, be careful. What number is b? Because you're careful. 110. What number is a? So when I divide, what is the width I need to maximize the area? 55. It said the dimensions. Dimensions is length and width. So the length is 110 subtract the width. Guess what the length is? Also what number? So what dimensions would maximize the area? So the answer is a region of 55 feet by 55 feet would maximize the area. So obviously 55 by 55 is a square, right? And we know all squares are rectangles. They're special rectangles. Let's look at number 20 and number 21. We're going to do two more together. And the questions we didn't do for stories is your homework, and then there'll be a quiz tomorrow. Okay. Number 20. You have how many feet of fencing? 68. And again, what shape is the region, the plot? The rectangle. But this time it borders on a river. That's going to be important. If you do not fence the side along the river, it says find the length and width of your plot. That would again do what? Maximize the area. So we're going to draw the situation. So again, we have a rectangle. But one side of the rectangle borders a river. So do I need to fence this part? So 68 feet, first of all, area again is length times width. Perimeter is twice the length plus twice the width. What does 68 feet represent? Is the perimeter. Now, for this situation, do we have two lengths and two W's? For this situation, I have one length and... So why don't I have two lengths? Is because the other one is a river and I don't need a fence. So if I solve for W, I would subtract 2W, right, to get L by itself. Then when I go back to the area, where there's an L, what can I put in? 68 subtract 2W. And then when I distribute, I would get 68W minus 2W squared. So if I want to know, like if the width was 1, that would give me the area, or 2 or 3 or 4 or 5 or 10. What I'm trying to find, though, is what width would maximize the revenue. And the word maximum, again, means you're finding the vertex. What formula helps us find the vertex? Is negative b over 2a. Be careful. What number is b again? 68. What number is a? So it's 68 divided by 4. So 68 divided by 4 is 17. So I know the width is 17. How would I find the length of that? Is you plug 17 back in for W. So 2 times 17 is 34, and 68 take away 34 is 34. So what would the length and width be to maximize the area? And if you feel I'm going too fast, this will be uploaded today, and you can go over it again and press pause and make sure you take your time. For most of you, it's a good idea to look at it again. Yes? It says a length of 34 feet and width of 17 feet would max the area. All right, this is our last question for today. Number 21. A lot of stories today, right? Consider the quadratic model h at t equals that. says for the height in feet h of an object t seconds after the object has been projected straight up into the air. It says find the maximum height attained by the object. Then it says how much time does it take the fall back to the ground, and then assume that it takes the same amount of time for going up as coming down. So let's start with this. Understand what each variable is. H is the height of the object, and t is time in seconds. So if I said, what's the initial height of the object? Do you know what number you plug in for t? 0. And initially it's 50 feet, right? And then it gets thrown straight up in the air and then it hits the ground. Do you see the quadratic equation there? If this is 50 feet? So step 1 is, how would I find the maximum height? Well, the word maximum means what again? Vertex. And to find the vertex, it's negative b over 2a. Our b in this case is 40. And our a is 16. And it's a negative 16. So you get 40 over 32. 8 goes in both evenly. That's 5 over 4, so that's like 1 1/4. That's not the question, though. The question is, what would the height be? And again, if I had this question, you'd be allowed to use your calculator. But to find the maximum height, you would then plug in the time into the height equation and solve it. So if I plug it in, 1.25, the answer is 75 feet. So what's the maximum height of the object? And you found it by using the vertex. The second part is, how much time does it take to fall to the ground? Well, if it falls to the ground, what's the height of the object on the ground? So I take the equation and make it equal to 0 and solve it. So I don't know if it's factorable. I'm going to divide everything by 2. So it's not factorable. So you also have this power with your 89 to find the solve button and solve this equation. So you'd have to use the quadratic formula to solve it, but I'm using my calculator. One answer is negative 0.9. That doesn't make sense, right? But the second answer is 3.415. That one does make sense. So how many seconds does it take for the object to hit the ground? All right. So here are questions today to do with quadratics, to do with business, to do with linear situations. Earlier we did different ones to do with mixture and to do with rate problems. All right, so this is Mr. G Math. Over and out. And now it's your turn. See you later.